Hello students. In previous class we understood about how to find the direction of electric intensity at a point. Today we will understand about uniform electric field and expression for electric intensity due to a point charge. Firstly, what is a uniform electric field is? It's very simple concept and understanding, but you must be very careful whenever we come across uniform electric field or at the time of deciding the field is uniform or not. Unless and until they mention in any electric field, if they're going to mention in the textbook, it is assumed to be uniform. What is uniform electric field? In a given electric field, if a test charge experiences electrostatic force of equal magnitude, this is important, equal magnitude and the same direction at all points in the given electric field, then that electric field is said to be uniform. Very simple. At any point in a given field, every point Coulombic force experienced by a test charge must be equal in magnitude and the direction of Coulombic force, that itself is a electric field direction, should be same at all the points. Not only magnitude, direction should be same at all points. Then only that field is said to be uniform. Be very careful. The same direction at all points is important. Magnitude we may get, but you have to decide the direction is same at all the points or not. This is an important thing you have to remember in uniform electric field. And the example to obtain the uniform electric field is at the equally charged parallel plate conductors. Yes, remember this exclusive situation where we can obtain easily uniform electric field. Uniform electric field will be produced between two equal and oppositely charged parallel metal plates separated between small distance. Then if you choose any point 1, 2, 3, here electric intensity direction is going to be the positive charge here. If you are going to keep the plus 1 C here, the force acting on the right side. Everywhere it is like this. The direction is same, and here if it is, don't get confused that the charges are going to be here, the points are going to be different distance, then how can the magnitude is going to be same? That will come across later. You just remember this exclusive example where we can get the uniform electric field. This is one of the situation. The uniform electric field will be produced between two equal and oppositely charged parallel plates. There should be metal or conducting plates separated between small separation. Then between the separation there is a field is uniform everywhere. If you keep the charge anywhere in between this plate, the force experienced by the Coulombic force experienced by the test charge is same. If you are going to keep a test charge here, then the Coulombic force, the electric field intensity is E, is everywhere it is going to be E. Electric intensity is E everywhere, the magnitude of electric intensity, and the direction is positive plate to negative plate. Then Coulombic force, the force by Q naught, then the Coulombic force is equal to magnitude of E and multiply by the charge. This F is equal to EQ naught. It is going to be same at all the points. Because of that, this is said to be example for uniform electric field situation. Please remember this. We come across this in the capacitor. In the capacitor plates, always there is equally and oppositely charged plates, between that there is always a field is uniform. Next, we will understand what is the electric intensity produced by an isolated charge, a single charge if I am going to keep. That is what the expression we come across this in a NCRT book. There's a standard question they are going to ask, derive an expression for electric intensity due to a point charge. See here we are derived the generalized equation, that is the Coulombic force. What is an electric intensity at a point due to a charge? See, if a charge Q is there and if I want to find the electric intensity at the point P, which is at a distance R, that is the generalized equation at electric intensity at P is going to be, electric intensity at P is going to be, as we understood earlier, the Coulombic force experienced by a test charge. I have to keep a test charge Q naught. Then the Coulombic force experienced by Q naught due to the source charge is Q, which is placed at O. Then divided by the Coulombic force experienced per unit charge. This is by Q naught. This is per unit charges Q naught again. This is what the expression we know general. Now the specifically we have to derive expression for, again, why they're going to ask this expression. If you are substitute this Coulombic force, because we know that how to calculate the Coulombic force. We use the word Coulombic force, but we are not substituted this value. Now if you substitute this value in this equation, we are going to get the expression for electric intensity due to a point charge. Very simple. I will take a charge at point O. The charge is going to be source charge, due to which we have to find the electric intensity. Then I am going to choose a point P at which I have to find the electric intensity. Then how to find the expression for it? This is what the standard way of deriving. We know that the distance is going to be, not necessary that always is to be along the line, horizontal line. You can choose anywhere in the plane. If the considered point is P, I have to find the electric intensity at P. Let this distance is going to have take it as an R. To find the electric intensity at P due to the source charge Q present at the point O, we know that the electric intensity at this point I have to keep a test charge. Let it be test charge be any magnitude of charge, but it should be very small. It is going to be Q naught. I will keep this a positive test charge. The thing is, I have to, for convention, I am going to keep the positive test charge. Then what is the magnitude? The magnitude of electric intensity at here at the point P is going to be, I will not mention it's a Q naught and all those things, simply I write electric intensity at the point P. E is the electric intensity at the point P. Here, to find this is the definition is F, Coulombic force experienced by the Q naught due to Q divided by the per unit charge is Q naught, where F Q naught Q is the Coulombic force. We know that if this is going to be kept in a medium, any medium means it has a epsilon R, dielectric constant, as we know. Then by the Coulomb's law, F Q naught Q is nothing but 1 upon 4 pi epsilon naught epsilon R in generalized equation, and both the charges, product of both the charges divided by the square of distance or separation between them into 1 upon Q naught. This is equal to Q naught get cancelled, and the electric intensity E should be equal to 1 upon 4 pi epsilon naught epsilon R in SI system and in the medium of dielectric constant epsilon r, then Q naught get cancelled by the definition of electric intensity and Q by R square. This is an actual expression for magnitude of electric intensity at a point due to a point charge, Q by R square. It is the magnitude. And what is the direction? Direction is the plus Q charge. This charge is also considered to be plus, then it is away from it. It is going to be plus 1 coulomb if I am going to consider here. Then it is going to be along the line joining OP, and it is here. This is the direction of electric intensity. Then this is along the direction along OP. Along OP. If it is a vector form, in vector form, if I am going to draw this is in the two-dimensional coordinate, then it becomes x and y axis. Then it becomes along the direction is the position coordinate of the P is x and y. This x and y plane, and this is I'll take this is a z. Then along this is a pxy. This is a position coordinate in the two dimension, and the Q naught is going to be present here. Then the E vector is going to be represented by, instead of along OP, we can represent 1 upon 4 pi epsilon naught epsilon r. I will call it as K. Next, Q upon R square, and this is going to be R in the direction of unit vector R. This is the vector form. This is a unit vector, or we can write 1 upon, this is a K. Instead of 1 upon, I will write K. Q upon R square. This R naught is nothing but, this is R vector divided by magnitude of R, and this is equal to K Q upon R square. This is R square R cube. This becomes R cube into R vector. This is what the expression for electric intensity of vector form. This is along the R vector, where R is in the two-dimensional is a xi plus yj. In three-dimension xijk, and in a simple along a one dimension along the line joining the two charges, 1 upon the magnitude is 1 upon 4 pi epsilon naught epsilon Q by R square. Here Q naught will not play any significant role in deciding the magnitude of electric intensity. This is what the expression we have to derive, and the main thing is understanding the concept is important. This is what we are going to derive in the board exam of NCERT. The same thing, the expression for electric intensity, same thing, Q is going to be kept here. This is R vector. When R vector, unit vector, R vector, at point P, I have to find the electric intensity Q naught. Then the Coulombic force direction is this. As a repulsive force, if I am going to keep a test charge, is going to be plus Q naught. And if I am going to assume plus 1c is going to be to determine the direction of electric intensity, it is a repulsive. And this is the direction of electric intensity too. Then expression of electric intensity due to point charge, the same thing, whatever I derived, I have printed here so that you can make the note very clearly without any mistake. Electric force F experienced by a test charge Q naught due to Q, due to the source charge. This is the source charge. Source charge, and force experienced by this one is going to be Coulombic force experienced by this Q naught is Q naught, that is a capital Q naught upon R square. where is the unit vector, where k is a 1 upon 4 pi epsilon naught in a given medium. If it is a medium, is epsilon r. If electric intensity is the electric field at the point P, the E vector is the electric field at a point P due to charge Q at O, then by definition of electric field in a given medium of dielectric constant epsilon r. Here I have not changed the medium as air, vacuum, or anything I have not considered, is any medium. Then any medium, it has a dielectric constant epsilon r. Then in the generalized equation, E is equal to F by Q naught by the definition of electric intensity or electric field definition, the magnitude. And this is a force experienced. This Q naught upon R square 1 upon Q naught. This is the definition. Then the Q naught get cancelled. The equation becomes, this is going to be the source charge upon R square. This is 1 upon 4 pi epsilon naught. The same thing. The whatever we derived, the same thing it will come here. The E, K, this is a 4 pi epsilon naught epsilon r, Q, Q, R cube by R vector is the vector form. Then, imagine if I change the medium, if the medium is air, for any given medium, I will name it as now E is a medium. Electric intensity, whatever we derived, the magnitude I am discussing, magnitude is going to be for a given medium. This is the equation we derived. This is a source charge. I am noted it is a capital Q. In a medium, then epsilon r is going to be for a dielectric constant or relative permittivity of a electric medium is epsilon r equal to 1, is greater than 1 for any medium. Any medium other than vacuum, air or space, what we discussed in the electric charges. Imagine if charges are kept in medium of air or free space or in vacuum, we know that epsilon r becomes 1. Then expression for electric field intensity magnitude due to point charge at the same distant point becomes, means at that time, if it is going to be this expression for Q and R, then for the same Q and R, but only thing is the medium is I changed to air. Then this epsilon r becomes 1. That is the difference. This medium becomes, now it's a medium is specific air. 1 upon 4 pi epsilon naught, epsilon is 1. The expression becomes the Q by R square in a medium of epsilon r equal to 1. This is the expression we have to derive for the board exam. First you have to consider, always keep in your mind, don't jump to the directly for a medium of air unless and until you have to check properly in which medium they asked to calculate the electric intensity in numerical problems. Even in the board exam, they are going to ask for the derived expression for electric intensity at a point. You had to come to the generalized equation. Finally, in for air or vacuum, this is finally air or vacuum, this is 1 upon 4 pi epsilon Q by R square. Note, see, the very simple, the same derivation and the alteration. The E medium is equal to 1 upon epsilon r, I kept here outside, and 1 upon 4 pi epsilon here, then Q by R square. Then 1 upon this 1 upon 4 pi epsilon r, this part is in air. Here 1 upon 4 pi epsilon Q by R square. If this is the thing, then E medium is equal to 1 upon epsilon r. This part is air. When this E medium and E air, when this is a E medium and E air are at the same distance from same source charge, means Q and R should be same for in the medium as well as when they kept in air.